Hello. The problem statement is data download duplication alert system. So what basically data download duplication alert system is that in an institute environment where multiple users need to access single same file, they download it multiple times. So to reduce the bandwidth of the server and reduce the load on the server, we a DDAS is needed. So the proposed solution here is Dupe Alert. So this is basically an extension which detects and prevents redundant file downloads by comparing file metadata, hashes, and file signatures, which are stored in a remote database system. So the how the idea is unique is that it merges two or three various different solutions. The first is hashing. It takes a bit of chunks from the file and it hashes it and stores in the database. So when a file is being downloaded, it will check those specific da- uh, data chunks and create a hash for it. And it will double check with the already existing hashes in the database system. That and file signature. File signature is another important feature that every single file has. It is a uh, unique thing which every file is associated with. So even if the name of the file is different and the content is same, the file signature doesn't change. So another file with the same name, with a different name, with same content is being downloaded, it gets detected automatically by file signature. And then it also comes down to size and a URL. So the first step is the checking of URL. If the URL is same, then we don't have to do all the additional extra processes. Also, this can be extended to audio and video files too by taking the binary data from them and making the hash of it. So the technologies we will be using are the JavaScript, React.js for the front end, then for backend Node.js. For storing this metadata, we will store it in either MySQL or MongoDB. Then Python we will use for creating the hashes and etc. And as you can see this use case diagram here, basically there are two entities, the user and the metadata database, where the user will send a request to download a data. So that request will go through three different paths. The It will first compare the URL, then will check file size with the metadata database entity, and where the part where it will generate hashes of the chunk, it will also compare with the metadata database and will decide whether it is duplicate or not, and it will return it back to the user. So the feasibility is, as you can see, there are technical feasibility is that that the database can efficiently store metadata, and chunk-based hashing is uh, computationally feasible as it is not too much of a data, and also it is within the ASCII values too. So and it is also scalable for large data sets. We can create the hash for the data set, which is a very small hash of at max 10 digits. Potential challenges and risks are scalability issues, where the database eventually grows so large that managing it can be difficult. So we can make it by partitioning the data into two parts, where we will check for the duplicates in one database and the information in the other database. Then hashing also takes a bit more much of a time, so it creates a lot of latency. To reduce it, we can use more optimized hashing algorithms too. And there are also possibilities of hash collisions. To reduce it, we can also use double hashing algorithms you may have heard of, or other strong hashing algorithms are there too. Then the flowchart is basically when the process starts, user initiates the file download. If the URL is not in the metadata, then it will say it is not a duplicate. Then if it is in the metadata, then it will check for the file size. If the file size is same, then the duplicate, then it is not a duplicate. Then it will stop, and it will go on, and then it will, if it is same, then it will go on to the hashing part. And if the hash is same, then it is said that it will be duplicate. Otherwise it will be not. So the potential impact on the target audience is that our target audience is the organizations to which the system will be delivered. For them, the bandwidth costs will be reduced. The resources cost will also be reduced too. And the benefits of the solution are economically, it will reduce as it reduces bandwidth. The cost to manage the servers will also drastically reduce. It improves the system efficiency too. Then, in technological aspect, we can access the file faster by not going to the actual data and downloading it instead of taking it from the server if it is already downloaded. And environmental wise, it will create a less load on the server, so the electricity cost will also be proportionally less. Here are the research and the references we refer to research the particular idea. Thank you.